Hi everyone, so I'm going to do a video on solving radical equations with single radicals. We will be doing radical equations when there's radicals on either side or more than one radical, but this video is only focusing on single radicals. So the first thing you want to do when you have a single radical equation is you want to isolate the square root or the cube root or whatever you have. In this problem I have a square root. Okay, so I want to isolate it. Right now it's the square root of v plus 3. I want to get the negative 1 over here. So what I'm going to do is I'm going to add 1 to both sides. That'll allow me to cancel this out. When I add 1 to 7, I end up getting 8. And that equals the square root of v plus 3. Alright, so now what I want to do is I want to solve for v, but there's a problem. V is inside of the square root. In order to get rid of my square root, I need to square it. That will release the things inside of the square root. Because a square root cancels out a radical. Well, a square root in this case. You have to do it to the other side in order to keep your equation balanced. So this will be 64. I'm going to subtract 3. And I'm going to end up getting v equals 61. Now you have to check your answers for square roots equations or any type of radical equations, because sometimes the answer does not work or does not satisfy the square root. And that's because during the squaring step you're creating another problem, like you're doubling things that weren't there. Like 64 wasn't in the original problem, so you're creating things that weren't there by the squaring. So always make sure you check yourself. I did show you in class how to check yourself on your calculator. Like you would put this side into y1 and that side into y2 and look at 61 on the table when x is 61, and if they equal, they're the same. But I'm going to do the long way by hand because I don't have a calculator on my screen. So I have v plus 3 minus 1 equals 7. I'm going to plug in 61. Okay, so, oh, I don't know why I put a radical there. That was silly. Okay, so minus 1 equals 7. Alright, so the square root of 64 minus 1 equals 7. That's square root of 64 is 8 minus 1 equals 7. And there you go, 7 equals 7. So our answer is indeed 61. Okay, for this one it's slightly different because I have a fourth root. And when you have a fourth root, you want to get rid of that fourth root. So we're going to get rid of it by fourthing both sides. So raise this to the fourth and raise that to the fourth. Those cancel. You'll end up with 2p plus 2 equals 3 to the fourth is 81. Because 3 times 3 is 9, 9 times 3 is 27, and 27 times 3, 81. Okay, also if you did this, I mean obviously you have your calculator, you get 9 and 9, and then there's 81. Okay, anyway, so subtracting 2, I get 2p equals 79. I will divide by 2 to get p equals 79 over 2. Okay, weird number, but we're not going to freak out, we're just going to check it. Maybe it is the weird number, so 79 over 2. So I'm going to plug in 79 over 2 as my check. So I have the fourth root of 2 times 79 over 2 plus 2 equals 3. Now, inside my square root, these 2's would cancel because it's over 1. And I have the fourth root of 79 plus 2 equals 3. 79 plus 2 is 81. And the fourth root of 81, if you went to math on your calculator and did the square root with the x symbol, you would get 3. So that weird number, 79 over 2, is actually our answer. Okay, so for this question, I'm going to isolate my radical. So I'm going to add 3. Cross that off. I have the square root of m plus 59 equals m plus 3. So now I want to get rid of my square root. I'm going to do that by squaring both sides. These would cancel. I end up with m plus 59 equals, now here's the tricky part of this problem. You have a squared and a binomial. Because we have a binomial that is squared, you have to write it twice. And you have to multiply it out by using box method or FOIL. You prefer FOIL. Box method, I'm sorry. So I'm going to do box method over here. Obviously, most of you, some of you, do FOIL, but I will do box. So I get m squared, 3m, 3m, 9. That makes my side here become m squared plus 6m plus 9. And that's equal to m plus 59. So as I said in class, when you are solving and you have a squared, so I have m squared, you want to make m squared equal to 0 and keep it positive. That's the only way you can solve it. Right now it's positive, so we are good. So we're going to keep it on this side. We're going to keep it on the right side. But these need to move over in order to make it move, in order to make it 0, equal to 0. So I'm going to subtract m and subtract 59. Cross out. I end up with 0 equals m squared plus 5m minus 50. Okay, because 9 minus 59 is negative 50. So now what I need to do to solve is I'm going to implement the AM method. I actually need to factor to do this. So I have m and m. AM method. I'm multiplying to a negative, meaning my signs have to be different. My factors of 50 that add to a positive 5 are 10 and 5. I end up getting m plus 10 equals 0 and m minus 5 equals 0. If you remember back in Algebra 1, you make like a little T-chart. So I'm going to subtract 10, and I get m equals negative 10, and I'm going to add 5. So I end up getting m equals 5, because 0 plus 5 is 5. So now I have two answers, negative 10 and 5, but I need to check them because we can end up getting answers that do not work. So I'm going to check my answers up here. So I have to check negative 10, and I have to check 5. So I'm going to plug in negative 10 first. So I have negative 3 plus the square root of negative 10 plus 59 equals negative 10. So let me make this a little neater. This is a negative 10. Okay, so I have negative 3 plus the square root of negative 10 plus 59 is 49. That's negative 3 plus 7. That gets us a positive 4. That does not equal the negative 10 that we plugged in for m. So I'm going to go down below here, and at negative 10, I'm going to cross him off, put a not equal to sign, and I'm going to say reject for him. He is called an extraneous solution. He arose during the squaring step. Okay, he's extraneous. He does not satisfy the original equation. So right now, we don't have negative 10 as an answer. But I am going to check 5. So I'm going to go up here and plug in 5 for m now. So I have negative 3 plus the square root of 5 plus 59 equals 5. I have negative 3 plus the square root of 5 plus 59, that is 64. That's negative 3 plus 8. Negative 3 plus 8 is indeed 5. So 5 equals 5. And that means that my solution for this question is only m equals 5. Negative 10 was extraneous. Alright, so for this question I'm going to cube root either side. in order to solve, because I need to cancel out the cube root here. So now I'm left with x minus 4 all squared. The cube root of 1 is 1. Now just like the last problem, I have to write this out twice in order to solve, because it's squared. A binomial squared you have to write out twice. Now you can do box method or FOIL. I'm going to do FOIL in my head just to save time. So I get x squared minus 8x plus 16 equals 1. So now, like the last example, you need to make sure that x squared is positive and equal to 0. Right now, x squared is positive, so I'm going to keep him on the left side. But to make him equal to 0, I need to subtract 1. I end up getting x squared minus 8x plus 15 equals 0. So now I'm going to factor in order to solve using the AM method in this case. The factors of 15 that add to a negative 8. Well, first off, I have a positive 15, meaning my signs will be the same. What are they? They will both be negative because I want to add to a negative 8. The factors of 15 that add to 8 are 3 and 5. In order to solve this, I'm going to split this down the middle, and I'm going to set both pieces equal to 0 and solve for x. Okay. Now what I'm going to do is add 3 to either side, and I get x equals 3. I'm going to add 5 to both sides, and I will get x equals 5. I need to check this answer in my original equation. My original equation is the cube root of x minus 4 equals 1. So I'm going to plug in 3 and 5 to check. So first I'm going to check 3. So I have the cube root of 3 minus 4 equals 1. That's the cube root of negative 1. The cube root of negative 1 is negative 1. So that does not equal 1. So I'm canceling that out, and I'm going to reject the solution for 3. He is extraneous. Extraneous meaning he does not satisfy the original equation. Now I'm going to check for 5. So I'm going to do the cube root of 5 minus 4 equals 1. 5 minus 4 is 1, and the cube root of 1 is 1. So 5 is your answer. Alright, I hope this video helped on solving single radical equations. I'll see you guys soon.